2, so times 2. Once we reach that stage, we simply multiply and write the answer. 4x square plus 2x plus x square, 2x square. Then we collect the like terms now. 4 plus 2, which is 6x square plus 2x. Right, even if you open this bracket, we should get the same answer there. Let's just do 2x cube plus x square. Differentiate that, you got 6x square. Differentiate that, you get 2x, right? That's the shorter way. This is the long way if the question looks like that. But as the questions become difficult, like the next one, so I hope you understood that, right? Let's try this one now, which is x cube. See, opening this bracket means times it by itself 4 times, then times by x cube takes a long time. So we use the product rule for that, okay? U is equals to x cube. Let's call it as x cube. And v equals to 2x plus 1 to the power 4. Right, we go a little bit slow here. It is important. I will find u dash first, which is a 3x square, and we are happy. That's pretty nice. This v dash, we have to go back to the chain rule. Very important. The chain rule stuff that we have done, right? Because there is a square cube. So let's say something to the power 4, when you differentiate, you should get 4 times the same thing to the power 3, which is 2x plus 1. Then multiply by differentiation of the bracket, which is a 2. Simplify that here itself. 2 times a 4, 8. And I have a 2x plus 1 to the power 3. So that's the v dash, that's u dash, and we know u and v. Finally, we simply substitute and we get the answer. Let's go a little bit back there. Right, the formula, we all know u dash v plus u v dash. U dash is a 3x square, right? So let's write that 3x square. V is that bracket, which is 2x plus 1 to the power 4. Plus u is a x cube, and v dash is also a bracket, please. So that's going to be 2x plus 1 whole cube. Sorry, there is a 8 there. Let's write 8 here. Okay. Now, we are not allowed to leave the answer like this, right? We are supposed to simplify a little bit. If there is a common factor, we take the common factor out, please. Okay. That's what we got. Now, let's see what is common. That's a single term. That's a single term. So I'm going to look at the numbers first. 3 and 8, no common. X square and x cube. X square is common. Now 2x plus 1 cube, 2x plus 1, 4. So actually 2x plus 1, 3 is common. That's the maximum common factor. When you take a common factor, we all know we used to start a bracket, right? So we do the same here, and then inside the bracket, right, whatever is left here we will write. X square is gone, so 3 is left. From 2x plus 1 to the power 4, 2x plus 1 cube is gone, so I'm left with 2x plus 1, just one of them. If you want, multiply them and then see whether you get this back. Plus 8 comes back. From x cube, x square is gone, so 1x is there, and 2x plus 1 cube, 2x plus 1 cube is gone, so nothing. That's what I have, but please remember, don't leave the answer like that. We need to open the brackets and collect the like terms inside the bracket there. So the first two remain the same. This is 3 times 2, 6x plus 8x, which is 14x, and then plus 3 times 1, a 3. So we leave it like that. Be careful, if there is a common factor inside the bracket with respect to the number, you must take that out. So that's the gradient of the given question there, which is x cubed 2x plus 1 to the power 4. So questions look a little bit longer. This expansion and taking the common factor, very important. Okay. That's example 2. We have example 3 here. We do by the product rule. That's u and that's v. Okay. So let's write u equals to 2x plus 5 to the power 4. Right. V equals to x cubed. Once we got that, we differentiate this. So I will write u dash. See, you need to know the shortcut here. Something to the power 4 is 4 times the same thing to the power 3, which is 2x plus 5. But we need to differentiate the bracket again, which is a 2. That's what we called as chain rule. Then we times this, so we differentiate this now. V dash equals to 3x square. Done. Okay. We got all the 4 ready. Now we will substitute in the formula, which is u dash v plus u v dash. Right, u dash, which is 2 times a 4, 8, right? So let's go slow. 8 bracket 2x plus 5 to the power of 3. Watch. That's u dash, right? We need v, which is x cubed, so times by x cubed. Plus, let's write u, which is that bracket 2x plus 5 to the power 4 times v dash is at 3x square. So that's at 3x square. It's just like the last one, right? You have to take some common factors out. So that's where we are. That's the question there. Number wise, that's a 3, that's a 8. So I can do nothing. Right, x square, x cube, watch, x cube, x square. So I will be taking x square common. Then watch these brackets. The brackets are very, very important. 2x plus 5 cube, 2x plus 5 to the power 4. Maximum common factor is 2x plus 5 cube. That's what we have. Once we finish taking the common factor, we start a nice big bracket. See whatever is left out that comes in. X square is gone from x cube. I'm left with x. 8 is there, so 8x. And that whole cube is already gone. It's finished. Plus, the number 3 comes. X square is gone as a common factor. From 2x plus 5 to the power 4, we took 3. So I'm left with one of them, which is 2x plus 5. Do not leave the answer there, please. Collect the like terms there. So it's x square bracket 2x plus 5 whole cube. And inside the bracket here, 3 times 2, 6 plus 8, 14x again. And then we have 3 times 5, 15. So that's the final gradient. M is equals to. And if you have a point, we can substitute the x value here to get the gradient and find the equation of the tangent. Okay, questions become a little bit longer once the problem is big, right? So just this taking the common factor, one should be careful. 3 examples. Let's do the 4th one. Copy that down and then try, please. That's u, that's v. Very important, right? U equals to, we write 2x plus 1 whole square. Then I do here v equals to 3x minus 2 to the power 4. That's what I have. And I differentiate both of them now. So I get u dash. Something's square is 2 times the same thing to the power 1. 2x plus 1, and we differentiate the bracket using the chain rule, please, which is a 2, and v dash is something to the power 4 is 4 times the same thing cube, right, which is 3x minus 2. Then we times by the differentiation of this, which is a 3. Watch there, there's a 3. Just simplify them. That's 2 times 2, 4 bracket 2x plus 1. This is 4 times 3, 12 bracket 3x minus 2 to the power 3. So we got all 4 of them ready. We just need to substitute in the equation, which we all know, right? We all know that u dash v plus uv dash. Okay, u dash, watch that, this is the u dash, so let me copy that, we need more space. 4 bracket 2x plus 1, u dash done. Multiply by v, v is there, 3x minus 2, 3x minus 2 to the power 4, please. Let me change the color here, plus u is that, u is that. So it's a 2x plus 1 whole square. Then it says v dash is this. Okay, so it's a 12 bracket 3x minus 2 whole cube. Sorry, yeah. So that's what we got. Then don't leave it there. Take something common. Let's see what is common, right? 12 and a 4. So I can take a 4 common, the first one. 2x plus 1 and 2x plus 1 whole square. So 2x plus 1 is common. From those two, 3x minus 2 to the 4, 3x minus 2 to the 3. So 3x minus 2 to the power 3 is common. Once you finish taking the common factor, big bracket starts and see what we get inside the bracket. 4 is gone, 2x plus 1 is gone. From 4 of them, 3 of them are out. So 1 is left inside, 3x minus 2, bracket please. That's done. Plus, in this, 4 is out. So 4 times a 3 is the 12. 2x plus 1 is gone from 2x plus 1 square. So I'm left with one of them. Common factors, very important please. 3x minus 2 whole cube. 3x minus 2 whole cube is common out. So that's what I get inside the bracket. Now our job is to just open the brackets and collect the like terms. So it's a 4 bracket 2x plus 1. This is already factorized, so please don't multiply them. 3x minus 2 cube. This one is, let's just do that, 3x, 6x, 9x, right, minus 2 plus 3, which is a plus 1. That's the final step, which is the gradient of the given curve. Okay, if they say find the gradient at x equals to 1, means substitute there 1, you should get gradient, then of course equation of tangents and normals. So that's about the finding the gradient using the product rule, right? We have a question here with a minus. I want you to try that please. The first bracket is a u, second bracket is a v. So u equals to x square minus 1. V equals to x square plus 1 to the power minus 2. Differentiate u dash, nice one, which is 2x, not big. V dash, be careful, we are in chain rule like. Something to the minus 2 is minus 2 to the same thing. So minus 2 times that to the power minus 3, that goes up by 1. That number 2 becomes a 3. X square plus 1. And then we need to differentiate the bracket. Do not forget that please, right? So differentiate the bracket, which is at 2x. Simplify a little bit more. Minus 2 times 2x minus 4x. Bracket x square plus 1 whole cube, sorry, whole to the minus 3. That stops there. This is fine, looks okay. Now we just need the u dash v plus uv dash story, right? Everything is ready for us. Simply we need to substitute, take the common factor. U dash, which is at 2x, let's write slowly, 2x there, times v is that x square plus 1 to the minus 2, right? So that's u dash v done. Plus, I'm going for uv dash, let's see, u is x square minus 1 inside the bracket, times v dash is this. So times by minus 4x, bracket starts x square plus 1 to the power minus 3, right? Any common factors we need to look for now, right? 4x and 2x, I can take, look, that whole thing is a single term. That's a single term. So I'm taking a 2x common, nothing wrong because that's a 4x there. And x squared plus 1 to the minus 2, x squared plus 1 to the minus 3. You got to see how much is common. Take the maximum common factor, right? Let's see what happens if you take that. Let's avoid getting minus signs. That's what I mean. So we can get x squared plus 1 to the minus 3 as common. See what happens now. Start big bracket. From this part, 2x is gone. X squared plus 1 minus 2, that's a minus 3. Now what do you multiply this by to get minus 2 back? Means that's x squared plus 1 to the power 1. See, minus 3 add 1 will give you minus 2. Bases are same. So you write the same base, add exponents because it's times. Plus x squared minus 1 is not a common, so that comes back. Number wise, 2x is gone, so I'm left with a minus 2. So actually that's a minus and then a 2. I'm left with x squared minus 1. People, that's how you do. Now, this is all right, which is 2x bracket x squared plus 1 to the minus 3. This part one needs to simplify, very important. X squared minus 2x squared minus x squared plus 1 plus 2 plus 3. I think we can leave the answer like that. That's the gradient of the given curve. Okay, 5 examples we have done. This is the next one. I will leave that with you. Try. Okay, this is u, this is v. See how you get along. Well, copy that and then solve on your own, please. Now, we actually finished the first 2 rules, which is called the chain rule and product rule. I have taken only the algebra examples for you to understand, then sin, cos, tan we will do later. It's the methodology, how you actually approach the sum, which is u, which is v, and when do you use the chain rule, very, very important. Now, the last one I'm going for is pretty much it's like product rule only, but it's called quotient rule. Okay? The quotient rule, quotient we all know, divide, right? The answer that you get. So the question looks like function x divided by gx. That's how the question looks like. Quotient rule we have seen. Let's just do one example here using the quotient rule. The first example, I'll go slow. Let u equals to the top number there, or the letter u equals to x, and v equals to 2x plus 3. So let's write them down. You differentiate this, which is a u dash, you get 1, and differentiate that 2x plus 3, which is a 2. That's all. Once we get those, we can actually substitute them into this rule. Let me write that rule again so that we substitute without any mistake. So it's u dash v first minus uv dash divided by v square. Okay, so I will substitute those values there. Watch please. We got u dash v. U dash is this, v is that. So 1 times that, you get 1 times 2x plus 3. And minus u is a x, v dash is a 2. So u v dash is nothing but 2x divided by v square, which is a 2x plus 3 whole square, please. 2x plus 3 and a whole square. Now numerator we need to simplify a little bit more. 2x plus 3 minus 2x, the 2x's cancel out. You are left with a 3 divided by 2x plus 3 and a whole square. That's the gradient of the given curve. That is the curve and that's the gradient. So it's more or less the same method. It's only that we have it divided by v square. Just be careful. Second question, you want to try, please copy that. 2x over 3x plus 2. More or less the same, exactly like the first one only. U equals to 2x. We do big sums later. V equals to 3x plus 2. and u dash is at 2, v dash must be at 3. The formula we know, u dash v minus uv dash divided by v square. It's nice to copy that down so that we don't go wrong. U dash v, right? So I will write 2 bracket 3x plus 2. That's a u dash, v is that, please. Minus, do not forget, u is at 2x times v dash is at 3. So that's easy to write, 6x. Divided by, it's the v square, it's the denominator square. So comes down to 3x plus 2 and a whole square. Okay. Then simplification, that's what I'm talking about. 2 times 3, 6x minus 6x gone, and 2 to 4. So it's actually 4 divided by 3x plus 2 and a whole square. That's the gradient of the given curve. You are not expected to open this bracket, not necessary, leave it like that only, because in some questions, what if you factorize the numerator and you end up get a 3x plus 2 as one of the factors, then you can cancel them out. So please listen, do not open this bracket, please. We have one question. I will leave this with you because it's more or less like the question number 2 or 1. So copy that and solve, please. I'll be taking the next one, which has a square root. Right, so that's the, please you do that sum. Question 4, let's do together. The top one is u, right? It's the quotient rule, fx over gx, u over v. So u equals to x square plus 1 and v equals to 2x plus 1 to the power actually a half because of the root. Then we differentiate both of them. So it's a u dash is a nice 2x, right? U dash is a 2x. V dash is actually half times, watch very carefully, half times 2x plus 1 to the power half minus 1, which is minus half, multiplied by, we differentiate the bracket, which is the chain rule, that 2 goes there. So actually what happened, the 2's cancel out, I'm left with that only. Okay, nicely done. So we got 4 of them ready. And the formula, please, u dash v minus uv dash divided by v square. U dash is this and v is that. So let's write 2x bracket, that's at 2x plus 1 to the power half. Use the red there, that's a half, please. So u dash v minus uv dash, u is x square plus 1 inside the bracket, v dash is that. Once again, it's the 2x plus 1 to the power minus half, please. Very important. Then divided by v square. I tell you what, leave the v square until the last step and put that back because we have no space here. So what we can do now is common factor. That's a single term, that's a single term. X squared plus 1, no x squared plus 1. 2x, no 2x at all. Right, but 2x plus 1 to the half, 2x plus 1 to the minus half. Right, which one will you take common is the most important thing. Let's take that minus half, very, very important. So 2x plus 1 to the power minus half is common. Now inside the bracket, the 2x comes back, 2x plus 1 multiplied by 2x plus 1 to the power 1, watch there. If you multiply those two, do you agree you will get a half? Because that's minus half plus 1. So don't take the half common, it's the minus half important. Minus 2x plus 1 to the minus half is gone out as common factor. We are just left with x squared plus 1. That minus is danger. So keep them inside the bracket. So this stays the same now, which is 2x plus 1 to the power half, or maybe a root. This one, let's open the brackets. 4x square minus x square, you have a 3x square. Plus 2x minus 1, so that's it. Plus 2x minus 1. If you want to factorize this, well, you can, okay. But that's the gradient of the... then don't forget, please, divided by